Today's lesson is about points, lines, and planes, the basic building blocks of geometry. By the end of the lesson, you will be able to recognize, describe, draw, and name these figures. You will be able to talk about the intersections between them, determine whether or not points are collinear or coplanar. You will be able to give examples of these objects in the quote-unquote real world and apply these ideas to the coordinate plane. So let's get started. The first building block you need to know is a point, and a point is just a location in space. It doesn't actually take up any space, it just describes that location. So if I want to talk about this location in space, I'm going to draw a little dot there. A dot represents a point, and I'm going to name it with a capital letter. So for example, I might name this point A to refer to that location. I might name this point T to refer to that location. A line is a geometric figure that consists of an infinite series of these points, all lined up, extending in both directions. Lines are named by 2 points on that line. So for example, I might have point A here, I might call this point B, maybe this one I might call point Q, this one I might call point T. And I can keep going forever naming points because there are infinite points on this line, and there are really infinite points between any 2 points because they don't take up any space. But I only need 2 in order to name the line. So I can call this line AB with a little line on top of it. I could call it line BT with a little line on top of it. I could call it QA. Doesn't matter what order as long as I'm just picking 2. Be careful not to pick 3 points on the line. Sometimes people want to pick 3 points because they see 3 points or 4 points because they see 4, but always just choose any 2 points on that line to name it. You can also name a line by a lowercase cursive letter, so I could call this line L if I wanted to. And the reason that we only choose 2 of the points is because 2 points uniquely determine a line. If I were to pick 2 other points, say X and Y, and draw the line that passes through X and Y, that is a unique line. There is only one line I could have drawn there. If I were to try to draw another one, also through X and Y, I would get exactly the same line. So this line is unique. There is only one of them. I can call it line XY with a little line. I could call it line YX with a little line. Or I could pick a cursive letter M and call it line M. So like we said, there is exactly one line through any 2 given points, any 2 particular points. And when we talk about points that lie on a particular line, we have a special name for them. Those points are called collinear. Co meaning the same, and linear, if you remember from Algebra 1, when we talk about a linear function is represented by a line. So linear for line, collinear, they are on the same line. So in our examples above, points A, B, and Q are collinear. Points B, Q, and T are collinear. So A, B, Q, and T, in fact, are all collinear. When we have points that do not lie on the same line, we simply call them non-collinear. And in our examples above, for example, A, B, and X are non-collinear. If I were to draw a line through A and B, it would not pass through X. Lines can have one of 2 relationships with each other. Either they can be parallel, meaning they never intersect, or they can intersect, and those are really the only 2 options. So in this diagram here, these 2 lines are parallel. This symbol right here means parallel, meaning that they never intersect. In this next example, these 2 lines intersect right here, and in the last one, we can't see an intersection point, but since lines extend forever, we know that if we were to extend these lines, they would, in fact, intersect here. So the intersection of two lines either doesn't exist because the lines are parallel, or they intersect at a point. So if we look at the second example here, if I call this line M, and I call this line N, and I call this point Z, then I would say that M and N intersect at Z. In geometry, we often want to refer to just parts of lines. We might be talking about the edge of a room, or we might be talking about the length of a piece of paper on your desk, or the length of the pencil in your hand, and we need to refer to just pieces of these lines. And these pieces are called line segments or segments. So a line segment or segment is a part of a line with two endpoints. So for example, if I want to refer to just this part of this line right here, I would just name the two endpoints. Let's call that C, and let's call that one S. And I'm referring just to the part of the line from C to S, and in order to do that, I just put CS and I put a little line segment with no arrows on the top. And we always name points by their, we always name line segments by their endpoints. So on this one over here, if I have this point is A and this point is D, I could call this segment AD, or I could call it segment DA, but those are my only two options. If I had a third point in here, and I talked about segment AC, I would be referring only to this part of the segment. That would be segment AC. A ray is a part of a line with one endpoint. So for example, if I want to talk about everything on this line from here on, I can refer to this as ray A, and then any other point on here, B or C or D or R, but I have to start with A. So I do A, R for example, or I could call that same ray A, C, because even though we're really particular about the endpoint, it goes on forever past the next point, so it doesn't matter which one we choose. But we are only allowed to choose 2 points, just like when we're doing segments and just like when we're doing lines. So if I want to name this ray over here, if I choose the endpoint X and some other point on here, Y, I would call this ray X, Y, with the arrow going over the Y. If I had one drawn this way, I'd have to pick another point, A, B, and I would call that A, B. Endpoint first, and then some other point. So the third major figure in geometry is a plane, and a plane is two-dimensional. We had points that were zero-dimensional, lines that are one-dimensional, and a plane has 2 dimensions. And really, they extend forever, but when we talk about planes, sometimes we mean a part of a plane, and we use the same word for both. So for example, a wall is part of a plane, but it doesn't extend forever. So even though we might call it a plane, we mean just that part of it. Generally, when we talk about a plane, we mean that it extends forever in its directions. So we need 3 points to determine that plane. So in this plane, I might pick this point and call it A, this point and call it B, and I need a third point that determines the plane. If I just put a point here, it would be no good, because it could be any plane that goes through that line. So I need a point that is not on the same line to name the plane. So I could call this plane ABC. But also there's a shortcut. I can name it by a cursive letter. So if I put a capital cursive R here, I could also call this plane R. Notice that if I had another point on here, say D, I would not include that in the naming of the plane. I could call it ACD or ABD, but I would not refer to that plane as ABCD. You just pick 3 letters, just like with the line we pick 2 letters, with the plane we pick 3 letters, just the minimum number to determine the plane. And one plane that you spent all of last year working on is the Cartesian plane, or the XY plane. So we will be working with that as well this year, doing analytical geometry, meaning on the coordinate plane. So anytime 2 planes intersect, they intersect in a line. So if I have one plane going one way, one plane going another way, so that they intersect, for example, 2 walls in our classroom, or 2 walls in whatever room you're in right now, the intersection, or the edge where they meet, is a line. So either 2 planes intersect in a line, or they can be parallel, and these are parallel planes. For example, the ceiling and the floor are hopefully parallel in the room that you're in, and those planes do not intersect. And just like with lines, where we had collinear points on lines, we also can have coplanar points on planes. So points that lie in the same plane are called coplanar. And points that do not lie in the same plane are called non-coplanar. And we have to be a little bit careful here, because if I pick any 3 points, they determine a plane. So if I'm talking about points that are not coplanar, they would need to be on 2 different planes, even if they're not quite drawn in. So for example, in the diagram below, we have one plane, then we have part of another plane here, part of another plane here, and we have part of another plane on the front here, and we also have this plane down here as well. And so there are 4 planes drawn into this picture, but remember, we could also talk about plane YRP if we wanted to. It's just not drawn in here. So to talk about coplanar points, we need to refer to at least 4 points in order to even have that discussion, because any 3 points determine their own plane. So for example, I have points Y, X, and Z determine a plane, but point Q is also in that plane. So I would call those 4 points, X, Y, Q, and Z, coplanar, since they all lie in the same plane, that red plane there. Non-coplanar points might be, for example, X, Z, and P all lie in the yellow plane, but now that I've determined the plane, R is not in that plane. So R is not coplanar, or excuse me, those 4 points are not coplanar because they do not all lie in any particular plane. So at this point, we have talked about points, lines, and planes, how they intersect, what it means for points to be collinear or points to be coplanar. We've talked about how to name these points, we've talked about how to name their intersections, and you should stop the video right now and write down any questions that you have about anything that we've talked about so far, because we're going to move on to applications of these ideas. Okay, so now that you've got your questions down, we're going to talk about what it means when we're looking at points and lines on the coordinate plane, or the XY plane, or the Cartesian plane that you talked about for all of last year. So in this example, we're saying that line L passes through points A at -2, 2. So I'm going to put point A on my plane, and point B, point B is at -3, 4. So there's point B. And now I need a line through A and B, and that's line L. So if I want to find another point that is collinear with A and B, I need to find a point on line L. And just to be exact, I'm going to use my slope here a little bit. So I'm going to count, let's see, from B to A I would be going down 2 over 1. So I'm going to go down 2 over 1 again. That's a nice easy point to pull off. Let's call that point C, and I'm going to say another point that is collinear with A and B is point C at -1, 0. And there are infinite correct answers to this question because there are infinite points that lie on that line. I just picked one easy one. If you want to pause the video right now and try to find another one on your own, you should definitely do that. The easier thing to do here is to find a point that is not collinear with AB. To find a point that's not collinear with AB, I pick any point that is not on that line. So, I don't know, I could pick, for example, this point right here, 8, 0, and call that point D. And I could say that D is not on line L or not collinear with A and B, and D is at the location 8, 0. So now that we've talked about points and lines and planes and pieces of lines, such as line segments and rays, and how these objects intersect with each other and how we name them where they intersect, we've even talked about how we can use them on the coordinate plane. We also just want to mention how you really see these things in your everyday life. And just to make that connection a little bit more obvious for you, I've given you some examples of how we use points and lines and planes and segments and rays and intersections here. So in our first example, we have streets represented either by lines or by segments if they're dead ends, or by rays if they start at one space but they go on, in this case, not really forever, but in maybe this particular city forever. And we have all of those things represented in that first diagram. Notice that the intersections of the lines, the streets, are represented by points, which really are like intersections. Over here we have a map of Florida, and all of the cities are represented by dots, meaning they're points. I really like this revolving door one. It shows a bunch of intersecting planes. So I have this door is a part of a plane, which we also call a plane. We have this door, which is part of a plane, and note that they intersect at this pole here, which is a line. And then I really love this one-point perspective, and we will do some one-point perspective later in the wintertime. But just as an example, you'll see all of the segments and pieces of planes and where all of these intersect. So for example, in this building, this wall, which is a plane, intersects this wall, which is a plane, at a line. We have this sidewalk edge intersecting with this sidewalk edge at a point, etc. So that's it for today's lesson. We're going to just review the objectives that we had, and then we're going to give you a couple of problems to try. So as you're making notes for tomorrow's class, you should make sure that you can do the following. Can you recognize, describe, draw, and name points, lines, and planes? Can you describe and name the intersections of these figures? Can you determine whether or not points are collinear or coplanar? Can you give examples of points, lines, and planes in the real world? In other words, can I give you a picture and you tell me what objects are being modeled in that picture? Can you find a point? Can you find an edge that is a line, etc.? And can you use these ideas on a coordinate plane, at least in the example that we did? And we'll do some more examples in class. So write down any questions that you have right now. And when you finish writing down any questions, go back to the website and try the self-check quiz. After you've done the self-check quiz, you can have it checked, and then you can even have it emailed to you. And then depending on who your teacher is, they might want you to forward your results to them as well. So thanks for listening, and good luck with the self-check. See you tomorrow.